Hello everyone, I welcome you to the Mechanical Operation course. In this video, we are going to discuss about the particle size reduction. I am Rajkumar, Assistant Professor, Department of Chemical Engineering, Hindustan College of Engineering and Technology, Coimbatore. What is the meaning of size reduction? Size refers to the physical dimension of an object. If reduction refers to the decrement or the process of decreasing the size. What is the definition of size reduction? We can define the size reduction as the operation carried out for reducing the size of bigger particles into smaller particles, or we can define reducing the size of bigger molecules into our desired size and shape by use of external force. We can name size reduction in terms of comminution. It is another term used for the size reduction. As picture represents, the molecules of huge size is reduced into small size, which is for our operations, desired operations. What is an objective of size reduction? In most of the processing industry, size reduction is mainly done in order to increase the surface area, because in most reactions involving solid particles, the rate of reaction is directly proportional to the area of contact with a second phase. If the surface area is very high, the rate of reaction will be very high. The second main objective is breaking a material into small particles in order to separate the valuables among the two constitutions. For example, separation of gold minerals from the ore minerals. So this is the best example for the size reduction. The next objective is achieving intimate mixing, or we can say is a perfect mixing, is the another main objective of size reduction. The next objective is to dissolve solid waste very easily. Another one is the to improve the handling characteristics. Next one is the to mix solid particles more intimately. What is the mechanism of size reduction? There are four main mechanisms which is used for the size reduction of solid particles. The first principles is the cutting. Here the material is cut by means of sharp blades. Example, cutter mill. This principles is mainly applicable for the cutting of rubber materials and plastic materials. The second principle is the compression. In this method, the material is crushed between the two solid objects by the application of external pressure. The example for this principle is the roller mill equipments. The third principle is the impact. In this principle, the material is more or less stationary, or it is hit by an object moving at a high speed, or when the moving particle strikes a stationary surface. The example for this principle is the hammer mill. The fourth and foremost principle is the attrition. In attrition, the material is subject to a pressure as in compression, but the surfaces are moving related to each other. Due to this movement of particles, the resulting in shear forces which breaks the particles into very fine sizes. The example for this principle is the fluid energy mill. This is the pictorial representation of the mechanism of size reduction. The first diagram represents the impact principles, where one particle is stationary, another one is the moving, which applies the external force. The second picture represents the attrition principle, where two objects move in two opposite directions. In between this object, the material is crushed due to the shear force of these moving objects. The third picture represents the shear force or cutting principle. Here, the material is cut by the cutter blades, by moving in one direction. The fourth and foremost principle is the compression, where the material is compressed in between the two solid objects by means of compression. Apart from these four principles, the size reduction can be classified into mechanical and chemical. In mechanical, it is further classified into external forces and special forces. In chemical, we can call it as a chemical forces. So these are the different forces which is used for the size reduction, but these principles is only applicable for the special cases. These are the different size reduction techniques or different size reduction terminology which is used in the process industry. First one is smashing, second one is the breaking, third one is the attrition, fourth one is the splitting, fifth one is the cutting, sixth one is the crunching. These are the different size reduction techniques based upon the principles. Next topic is classification of size reduction equipments. As we know, for the size reduction, we need the size reduction equipment. So, these size reduction equipment are classified based upon the particle size we are crushing. For crushing of core size material, we will use the crushers. That is the first classification of size reduction equipment. Example for this crusher is the edge runner mill and end runner mill. The second size reduction equipment is grinder. This equipment is used to reduce the intermediate particles. In that, we are having four different types of equipment, that is impact mill, rolling compression, attrition mill, and tumbling mill. The third size reduction equipment is the ultrafine grinder, which is used to reduce the intermediate particle into very fine particles by the principle of attrition. The equipment which is used for this type of grinder is the fluid energy mill. The fourth equipment is the cutting machine. The example for this equipment is the cutter mill. The next topic is factors which are affecting the size reduction operations. There are different factors which are involved in the size reduction operation. The first one is the toughness. Toughness of material is sometimes more important than the hardness. If the material is tough, it is very problematic for the size reduction than a hard and brittle substance. For example, it is difficult to break rubber than a blackboard chalk piece, right? Toughness is encountered in many pharmaceutical applications, particularly in fibrous ducts, and is often related to moisture content. Foremost parameters which affect the size reduction is hardness of the material. Hardness is a surface property of the material, or it is frequently confused with the property that could be better described as a strength. In general, the harder the material, it is more difficult to reduce the size of the material. The hardness is represented as in Mohs scale. If the Mohs scale value is equal to 1, it is a graphite material. If Mohs scale is less than 3, it is a soft material. If the Mohs scale value is greater than 7, we can call the material as hard material. If Mohs scale is equal to 10, we can say the material is diamond. The next factors which affect the size reduction is abrasiveness of the material. It is a property of a hard material and which is limit the type of machinery that can be used for the size reduction operation. Based upon the abrasiveness property, we will choose the exact or particular equipment for the size reduction. During Why? Because during the grinding of some very abrasive substance, the final powder may be contaminated with more than 0.1 percentage of metal worn from the grinding mill. The fourth and important factor is the stickiness of the material. If stickiness is very high, it causes the difficulty in size reduction. If the material other to the grinding surfaces or meshes or screen, it will reduce the efficiency of size reduction. During the size reduction operation, if the equipment produces heat, the gummy materials can be melted and it will create troublesome to the size reduction process. In many process, in order to avoid stickiness, we will add the inert substance to successfully complete the size reduction operation. The remaining factors which is affect the size reduction are the softening temperature, material structure, moisture content, purity required, ratio of feed size to the product ratio, bulk density, and physiological effect. So these are the remaining factors which also affect the size reduction operation. Thank you. I hope you all understand.